All right, we're ready to start chapter 7. Chapter 7 is on rational functions. Remember, whenever you see the term rational, those first 5 letters mean a lot. That means these are all going to be fractions because that ratio is a fraction. So start off with the chapter 7 opener. It's just got a couple of things in it. First is adding and subtracting rational numbers. When you add or subtract, you have to make sure you have a common denominator. You've done this before in algebra. So you want to look and make sure you have a common denominator. Like here, our two denominators are 4 and 3. Well, the smallest thing they have in common is a 12. So we're going to write each one of those as 12s. So 4 goes into 12 3 times. 3 times 3 is 9. So that's a negative 9 12ths. 3 goes into 12 4 times. 4 times 1 is 4. So we've changed those two fractions into 12s. Now we can combine them. A negative 9 12ths plus 4 12ths is negative 5 12ths. The second one, here we're subtracting a negative 5 eighths. Now notice they both already have a denominator of 8, so we don't have to worry. We have a common denominator already. So minus a minus is plus a plus. So 7 eighths plus 5 eighths is 12 eighths. Now we need to do two things to that. First of all, there's a common factor of 12 and 8. Well, 4 goes into both of those, so we can do that. 4 goes into 12 3 times, 4 goes into 8 2 times. So that's the same as 3 halves, which is a perfectly acceptable answer. If you did this on big ideas math, it might want you to write 1 and 1/2. In algebra terms, actually 3 halves is a better answer, but they may want you to change to 1 and 1/2. All right, the next thing is simplifying complex fractions. This is very important. As you get higher in math, you get more and more complex fractions. It seems like in trig and pre-calc, I have to say this over and over and over, this same thing. Multiply the numerator by the reciprocal of the denominator. A complex fraction means there's a fraction within a fraction. So here the top is a fraction and the bottom is a fraction. So there's a fraction in the numerator and a fraction in the denominator. It doesn't matter, there could be just one and not the other, but when you have a fraction within a fraction, that's called a complex fraction. To solve that, you multiply the numerator by the reciprocal of the denominator. So you take the top times the reciprocal of the bottom. So here the top is 1/2 times the reciprocal of 4/5, which is 5/4. So top times the reciprocal of the bottom, numerator times the reciprocal of the denominator. Remember, when you multiply fractions, you just multiply across. Numerator times numerator, so top times top is 1 times 5 is 5. On the bottom, 2 times 4 is 8. So that simplifies to 5 eighths. This next one, if you notice, the bottom is 2 fractions. So first, we need to get a single fraction there. So we're going to leave the top alone, 16/5. On the bottom, to subtract 5 halves minus 5 eighths, we need a common denominator. Well, a common denominator for 2 and 8 is 8. Well, that one's already 5 eighths, so we can leave it. Here, if we change 5 halves into 8, 2 goes into 8 4 times. 4 times 5 is 20. So that denominator now is 20 eighths minus 5 eighths, which is 15 eighths. So the first thing we did was get a single fraction on the top, a single fraction on the bottom. Now we take the numerator of the top, 16/5, times the reciprocal of the bottom, 8/15, and multiply straight across. 16 times 8, 6 times 8 is 48, and 4, I believe that's 128. 5 times 15 is 75. So 128 over 75. Or if they wanted a mixed fraction, 75 goes into 8, 128 one time with, I think, 53 left over. So you could do that. Again, I prefer 128 over 75. And that's it for 7.0. So you have adding and subtracting, which means you get a common denominator, and you have complex fractions. Take the top times the reciprocal of the bottom.